Welcome to my YouTube channel Learn Electronics. We'll have some fun learning electronics. Today we are going to see a PN junction diode. From that we are going to see learning objectives, introduction, diodes, rectifier diodes, their fabrication techniques, construction of a diode and operating principle of a diode. In learning objective, we have to understand the concept of PN junction, to know the mechanism across the junction when junction is formed, to understand the forward and reverse bias of the junction, to understand the construction, working and applications of a PN junction. Finally, we have to see a Zener diode, its construction, working and application. In introduction, as we know, the solid-state electronic devices have revolutionized the world of electronics because of their lightweight, small size, high efficiency and great life expectancy. Example is mobile phones. They are light in weight, smaller in size, highly efficient and they had great life expectancy. Still, these devices has some disadvantages like temperature dependence of characteristics, highly inherent noise and may they operate in between some frequency, so we can say frequency limitations. The semiconductors are very important in case of a solid state electronic devices. As we know, semiconductors are the substances whose electrical conductivity lies between conductors and insulators. Modern state electronic devices are manufactured with the use of materials, we can say semiconducting material such as germanium, silicon, selenium and gallium arsenide compounds. In case of a semiconductor, they have negative temperature coefficient of resistance, means the increase in temperature result in a decrease of resistance. The resistance of semiconducting material is affected by the impurities available or present inside a semiconducting material. They also affected by the action of light. They also affected by some electrical field. Means we can have some various applications where we can use this semiconducting materials. Now we have two types of semiconducting material. One is called intrinsic. So extremely pure semiconducting materials, or we can say semiconductor crystals, is called as intrinsic semiconductor. When impurities are present in the semiconducting material, we can say that material is called extrinsic semiconductor. So extrinsic semiconductor plays very important role when we have to have solid state devices. So we have to make intrinsic semiconductor, they are easily available, to extrinsic one. So how to convert intrinsic semiconductor to extrinsic? So they had a process of adding impurity. So the process of adding impurity is called as a doping. So by using doping concept, we can convert intrinsic semiconductor material into extrinsic semiconductor material. So depending upon the type of impurity added, the extrinsic semiconductors are also classified as p-type semiconductors and n-type semiconductors. So p-type semiconductor where the trivalent impurity is added, while in n-type semiconductor a pentavalent impurity is added. Now we have two materials, p-type material and n-type material, but they separately have very limited use. So what we have to do, we have to make them together to create a PN junction. So we can have a PN junction by either creating a ground junction technique, alloyed junction technique, diffuse junction technique or ion implementation method. They will produce rectifier diode. So with control of various parameters at the time of manufacturing, we can convert diodes into a rectifier diode, a switching diode, a varactor diode, Zener diode, light emitting diode, LED, photodiodes, we can produce it. So different types of diodes, they have different characteristics, they have their own properties. That's why they are using in various applications. Instead of only one PN junction, we can have two PN junction. So we can have bipolar junction transistor from that 2 PN junction device. In 3 PN junction, we can create SCR, we can create track. In this way, by using semiconductor material, various type of devices, we can say solid state devices, are produced like diode, transistor, diac, triac, SCR, UJT, FET, and various MOS devices. In case of a diode, so we have a diode, a two-terminal device that can pass a large current in one direction and almost no current in other direction. So this is called as a diode. Diode means anode, means two anode. We can say two electrode. So why we have only current in one direction and there is no current in other direction? This is due to the construction working of a diode, which is nothing but a PN junction. Now in PN junction we have a p-type semiconductor having holes as the majority carriers, and n-type semiconductors, these semiconductors having electrons as the majority carriers. A PN junction is formed by introducing donor impurity, n-type material, into one side of acceptor impurity called a p-type material. So we can have a single crystal of semiconductor as silicon or germanium, where we can form a diode. It should be noted that a semiconductor diode cannot be made by bringing two different material like p-type, n-type into contact, but they should be diffused into a single crystal. So depending on the nature of PN junction and its various characteristics, different types of diodes are manufactured. They may be a rectifying diode, switching diode, Zener diode, LEDs, photodiode, etc. So these diodes are available in the market with different technical specification. Their specifications are quoted in data manuals. If you have to refer this particular diode, you have to go and refer the manual. Then you can use the particular diode for designing in a circuit. Look at here a rectifier diode, circuit symbol of a rectifier diode where a triangle and a bar connected together to form a diode. The triangle part is called as anode and the bar part is called as a cathode. So this is a circuit symbol of a diode where this triangle means it as an arrow. So this arrow will indicate the current direction. So current will flow from anode to cathode. There will be no current from cathode to anode. The actual diode, if you go in a market, you will look like this, where the golden ring indicate that is nothing but a cathode and the other part is called as a anode. We have seen that we can form a semiconductor diode using different fabrication techniques. So we have these fabrication techniques anyone can use to form a semiconductor diode. We can have a grown junction technique, we can have alloy type or fused junction diode, we can have diffused junction technique, we can have epitaxial growth or planar diffused diode, and lastly we can have point contact diode. So any of the fabrication technique that can be used to create a diode. So we can see one of the construction of a diode, one of the technique used to construct a diode. A PN junction diode is basically a rectifier diode which is constructed by diffusing p-type and n-type of semiconductor material together. They are having many techniques like grown junction technique, alloyed junction technique, diffuse junction technique, and ion implementation junction technique. So we can see one of the technique to have a construction of a diode. So it is very important to know that different terms regarding formation of a PN junction. Look at here, a germanium n-type semiconductor material is taken and over which a indium that is called a trivalent impurity is put. So here a germanium crystal over which a palette of trivalent indium like impurities placed. That is a p type of material. So the next stage is that these materials are heated to a temperature of about 450 to 500 degrees centigrade. The palette of indium and a part of germanium, it gets melted. The proportion of germanium to indium in the alloy melt is greater than the solid solubility at room temperature. Hence, the liquid indium and some part of the molten germanium are mixed. You can see in the diagram where we have molten indium and germanium, they are mixed together, indicated in a black color. So what we have to do in the next stage, we have to cool them. So cooling takes place. Germanium comes out of the alloy mixture on account of the reduced solubility. So from that, the interface between the cooling mixture and the germanium crystal is a regrown region with the indium added to it. The addition of indium overcomes the excess of electron in the n-type material such that it creates p-type of region. So we have now p-type of material and germanium n-type, that is the main base of the semiconducting material. So we have formation of a p-n junction by using grown junction technique. So this regrown junction or region have same lattice structure as germanium crystal but large number of indium atoms added into it. So thus the germanium is n-type semiconductor and regrown p-type material on it gives us a p-n junction, and for connection we have above that regrown junction a connection. That connection is for anode and the germanium n-type where we can do any connection to form cathode. Now when the germanium and indium are alloyed together, they form a p-n junction. The surface that separate the p and n region in a single crystal diode is called as metallurgical junction. You can see in the diagram where we have metallurgical junction, n-type material on one side, p-type material on the other side. So this figure will show the situation of formation of a p-n junction at the instant just the starting of diffusion process. So at the diffusion process we'll have some holes on the n-type side and some electrons from n-type towards the p-type side. So these two metals diffused to each other in liquid form and they solidified. Some of the free electrons in n region are spread out towards the p region and they becomes a minority carrier. The electron which has entered into p region, it recombines with hole in p-type material and negative ion is created. So this process continues with the electron diffusion and they are creating pair of ions and they are shown within depletion region. So in depletion region, the ion cannot move like the electron or holes. Such a number of ions situated near the junction is depleted of free electrons and holes. So that's why this region is called as a depletion region. Now the question is that when the process of the creation of ion is stopped. So at a certain point the depletion layer will act like a barrier to further diffusion of free electrons across the junction. So this certain point is because of creation of so many ions which repel the electron back to its original position and further combination with the hole is stopped. So the creation of ions stopped. The width of depletion layer keeps increasing with each crossing electron and they are recombining with the hole. But when the equilibrium is reached, the internal repulsion of depletion layer stops further recombination of free electrons. So this difference of potential across the depletion region is called as a barrier potential. So within the limit of barrier potential, there will be depletion, but after it, there will be no depletion at all. The value of the barrier potential is approximately 0.7 volt for silicon diode and 0.3 volt for germanium diode at a room temperature, that is 25 degree centigrade. Now we have formed a PN junction diode. We can look at the symbol where I have seen that I have told that anode from where the arrow will be there towards the cathode. So that arrow will indicate the conventional current flow, whereas the electron flow will be reversed to that of the current flow. Keep in mind that current flow in the diode is nothing but a holes flow, and the electron flow is always opposite to the holes flow, means to the current flow. The operating principle of a diode, as the rectifier diode is operated by two ways, one is a forward bias, other is a reverse bias. But the basic operating principle of the diode is allow current to flow freely in one direction and no in other direction. Hence the name is diode. Because of this property of a diode, it is used as a rectifier to convert alternating current into direct current. The diode used for this purpose is specified as a rectifying diode. They have some special specifications about voltage, current and wattage rating, which is specified in data manuals. Now see the operating principle. Here a circuit diagram. It indicates that the diode is connected in a forward bias. So for biasing the diode, we have to use external battery with some current limiting resistor. So this RS is a current limiting resistor. This is used to protect the diode from higher current than its rating. So that's why it is connected in series with the diode. So here look at the circuit of a forward bias diode. In a first circuit with the circuit symbols, and next circuit where we can see how the P and N junction decreasing the depletion layer. So the positive of the battery is connected to P-type semiconductor and negative to N-type semiconductor side. This biasing is known as a forward biasing. The external applied potential pushes the holes and electron towards the junction, cause decrease in potential barrier. You can see from the diagram that as the potential barrier goes on decreasing, the depletion layer goes on thinner and thinner, and when it crosses the barrier potential 0.7 volt for silicon and 0.3 volt for germanium, the depletion layer vanishes and we'll get a large current through the PN junction diode. The hole and electron will crosses the barrier and combine, neutralizing to one another. This process continues as more and more holes and electrons are supplied by the positive and negative terminal of the battery, and hence a large amount of current flows through the diode from anode to cathode after the barrier potential. When the diode is operated in a forward bias, it will offer a very low resistance, is in terms of few ohms. Hence, it is worked as a closed switch in a forward bias diode. The voltage where the current through the forward bias diode starts increasing rapidly is called as a knee voltage of a diode. So, a barrier potential is also called as a knee voltage of a diode. 0.7 volt for silicon and 0.3 volt for germanium. Thank you. Thank you for listening my lecture.